thanks for introducing us, Margot. I'm very excited to be here, and I'm particularly excited to host this particular panel. It's very close to my heart. We're thinking about equity, and we're thinking about what is the role of algorithms, of models, of data to help us move forward. I should say that we intentionally decided to call this an equity panel rather than an inequity panel, because we really want to think about how do we move forward. We heard a lot about bias and the importance to contextualize this morning, and I think that was such a wonderful way of framing the conversation we want to have today here. So I have three wonderful speakers. Their bios are already in the leaflet. But I want to start with letting everyone just kind of briefly introduce themselves, what they do. They all work on equity with algorithms, with data, but from different angles. So why don't we start with you, Ling, and then we'll go through our wonderful speakers here. And why don't you tell us a little bit about what you're doing right now, and what does equity mean to you?
Hello, everyone. It's such an honor to be here. I learned a lot from the inspirational talks this morning, and I'm looking forward to learn more from this panel discussion. So as a research scientist in the Lawrence Berkeley lab, I actually wear multiple hats there. So the first hat I wear is as an atmospheric scientist, focusing on air pollution controls. So it's so important that having clean air to breathe. And it has intimate relationship with the equity issues. To give you some numbers globally, we have just the particulate matter pollution alone accounts for more than 4 million deaths per year. And also in the United States, the deaths caused by particulate matter pollution is twice as many as that are caused by car accidents. It's been well established in the literature that such a huge health risk factor is disproportionately burdened by the lower income and the racial minority groups. So moving forward, how can we minimize and avoid such environmental justice disparity? One of my recent work is to use air quality modeling tools and atmospheric sensitivity analysis to come up with pollution control strategies that can help benefit the disadvantaged communities in Central California. And this region is actually account for close to 70% of the most disadvantaged communities in the whole California region. What I'm very excited about is two of my upcoming projects, which continue this legacy, basically looking at the distributional effects in air quality and health burdens arise from the different deployment strategies of EV charging infrastructure, as well as decarbonization pathways in the transportation sector. The other hat I wear, I don't know if I'm running too long, but is as a data scientist and also domain scientist, which I tries to bring data science method into the building energy as well as the transportation research. Here, Jessica and Tierra probably will be more into these fields. The focus here, what I try to focus is mainly in the leveraging data and algorithms to bring the behavioral insights and build behavioral-based models. To me, this is related to equity because understanding the opportunities as well as the constraints that ultimately shape the decision context is the first step to to a equitable distribution of resources based on individualized needs. And they also help us to design policy levers that really address the barriers faced by individuals and help them to better achieve clean energy goals.
Thank you, Ling. That was great. And I think also already a lot of topics come popping up that will build on transportation, climate change, pollution, energy. Jessica, do you want to tell us a little bit about your work?
Yes, thank you. Thank you for having me here today. It's a real pleasure. I'm a mechanical engineer by training, and I've always been really interested in the human dimensions of the technologies and the processes that we're developing. I've spent my career working in buildings, building science and building technology, and I think that's in no small part because of the core role that buildings play for us. They're where we create our homes, where we work, where we educate our children and gather in community. And with a third of greenhouse gas emissions, the energy-related portion coming from our facilities, there's also the opportunity to do very societally relevant applied problem solving. So what we're finding right now is that we're in the midst of a really exciting energy transition. We're using data to curate nearly every aspect of our lives. And we're seeing this proliferation of data-driven technologies and services. For buildings, what that means is that we're increasingly able to use our facilities as the hub for the exchange of clean electrons in this clean energy economy. So we're integrating with renewable resources to power our buildings. We're able to modulate the consumption and loads in our facilities to better coordinate with those renewables, and even sometimes contribute that clean energy back into the grid. And more, we're also passing through those clean electrons into our vehicles, into our electric vehicles that are integrated through the buildings with our charging infrastructure. We're doing all of this today with a real newfound focus on equity and justice. And how that's manifesting is in real considerations to things like health and air quality. What are the implications of burning fossil fuels in our power plants, in our homes, in our appliances? Or things like poor condition facilities that may expose us to things like mold. We're aware of the problems of extreme heat and the urban heat island effect that's so acutely experienced in our Black and brown communities in each and every city across the country. And I would say finally, we're thinking a lot about who is it that gets to participate in this new clean energy economy. Mm-hmm. There's aspects here of workforce, and also I would say most critically, access to and ownership of our clean energy assets. Who is it that is able to reap the benefits of the rooftop solar, of the behind-the-meter battery storage, of the smart and connected equipment and appliances that are out there? Thank you.
That sounds exciting. Tierra, we already heard a little bit from your work.
Yeah,
do you want to build on that?
So I'll just add that I've been interested in transportation equity and how to advance equity in transportation since I started grad school. And I think that it's motivated really from growing up and seeing examples. I'm originally from Detroit, Michigan, and growing up and seeing examples of how place matters and how where you live, the modes that you have access to, they all dictate outcomes related to opportunity. So that was very real to me growing up. Once I got to grad school, I started thinking about all of these different cases. In Detroit also, there is a community known as Mexican Village. It's a high concentration of Hispanic residents. And it's right near the on-ramps for the Ambassador Bridge, which is connecting to Windsor, Canada, and is responsible for, I think, about 25% of all trade from North America to Canada. So you have this community that's located in this area that is known to have a high concentration of vehicle-based air pollution, but they are not necessarily benefiting overall in terms of economic, prosperity from their position. So these are all very clear examples to me, and they drive the work that I do. As I was able to mention earlier, I study these travel demand models and really the whole landscape. So how we collect the data, the relationship between the quality of the data and modeling outcomes, prediction accuracies, how well these models reflect conditions for vulnerable communities. And also, once we have improved data and improved models, using them to calculate measures that can inform decision-making in a meaningful way. And so I study all of these areas. And one of my interests, again, relating to the discussion earlier, is that there are a lot of social issues that drive the models that we end up with in decision-making. Those social issues don't always make their way into the data. And so I think it's really important that we start being more aware of this and trying to come up with ways to better reflect some of these broader, seemingly exogenous factors in our data and in our modeling.
And I think that's such a great point. I would love to build that out maybe a little bit more, because it's also something that we work in my group. We mostly do model development, and it is challenging, right? When you think about equity, that there is the quantitative side, there's the algorithm, the model that you're using, but there's so much context that is so essential. There's so many implicit assumptions that go in. That it depends both on, that govern how you set up the model, but also how you apply the model. Mm-hmm. So maybe let's do another round, and I would love to hear from each of you about what is the role that algorithms play and models play, and how can they help us move towards greater equity? So do you maybe want to build that point out a little bit more? Like, how can we move to a place where models are where the models are moving us towards greater equity rather than sort of repeating mistakes of the past or sort of enforcing our blind spots?
Yeah, absolutely. I think one of the really exciting things about emerging data sets that we have coming online is that we can explore things that we would not be able to explore without them. So I gave the example of leveraging TNC data to understand disparities in the quality of service. I think that these are things that we couldn't necessarily put clear numbers behind before. And so it highlights, a significant issue, and it also highlights, something about how this can happen. From a modeling perspective, so I think, I kind of glossed over this, but under the hood of travel demand models are essentially discrete choice or econometric models, right? These are models that are intended to preserve the causal effects, the behaviors, the why, the preferences of travelers, why they're making certain choices when it comes to their transportation. However, one of and I'm going back to challenges, but trying to make my way to the opportunities. One of the challenges is that we don't pay enough attention to the constraints, right? So this is tying back to the underlying conditions. For example, if I'm choosing to take transit today, to get to work, I'm making that choice under some constraints, right? There's some market conditions that sort of led me to that. It has to do with my access to travel modes. It has to do with predispositions towards a mode, perhaps. It has to do with my pocketbook. It has to do with some things that we can observe and some things that we cannot. And so I think that we spend a lot of time focusing on the choice process, not enough on the constraints. And with the advent of big data, we're starting to have an opportunity to understand more of those constraints in new and interesting ways. And so I think that's where the opportunity is. I think that we need to leverage the vast amounts of data that we do have about all parts of life and all types of activity to understand constraints that are not presented in traditional data sets.
Yeah, that's such an interesting point. Certainly, I think something we see in our research as well is that some communities have a lot more choice than others.
Absolutely.
And we tend to take that for granted, but then of course that has the risk of just like perpetuating existing inequities, right?
Exactly, and assuming that everyone has the same level of choice.
Exactly, just assuming that everyone had that. Jessica, do you want to share from your experiences? I'm sure that kind of theme has come up when it comes to energy transitions and building design, like some tend to profit more than others or tend to be more active in the choice and the design than others, or what is the experience?
I think in one respect, one aspect of that I've been considering in my work is the extent to which the tools or the techniques that we are interested in drive us down certain paths. So there's a lot of activity in the building sector now in the R&D side around control. And so it turns out up to a third of the energy or emissions in our buildings is wasted just through how we operate them. So much attention on control and advanced control, particularly learning-based methods. As it turns out, those are most powerful for very complex systems. When we have rooftop solar and behind-the-meter storage, and we have many, many knobs to turn. And so we start asking, is that leading us down a path where we're only designing solutions for the Class A high-end real estate or homes that feature these assets that we can then exercise our incredibly powerful models over. So it's, a lot of times the problem drives the tool, but sometimes the tool can drive what problems of focus you end up spending your attention on. I think similarly, as we develop more and more complex solutions that can handle diversity, are we able to maintain them and deliver them at different points across the digital divide, which we know is still prevalent and something we have to think about and grapple with if we're talking about economy-wide solutions.
An excellent point, yeah. Ling, you mentioned earlier that you're working on behavioral models. So behavioral models obviously try to bring in some of that human choice element or some of that social element. Can you tell us a little bit more about your experiences with those types of models?
Yeah, sure. Just in an example of travel behavior research, like modeling the choice of transportation mode that you choose, or what type of vehicle you own in your household. The traditional so-called, we call that gold standard methods are like discrete choice models, which are based on the random utility maximization theory. So it's borrowed from econometric. What I want to say is that it has been only scratched the surface that machine learning methods have been applied, because to me, machine learning methods, the uniqueness about it is that there's no predefined form that you need to fit, right? So you don't have to come up with a hypothesis and then test it. You just let the model learn from the data. And the traditional limitation of machine learning methods is that it has maybe superior performance at cases in prediction. However, the interpretation side, the people treat it as a black box. But in the recent advances in explainable AI, for example, the a so-called explanatory tree, which applies to all these tree-based methods, like the first datathon winner, like boosting method is a tree-based classification method. So these methods can be interpreted using so-called Shapley value, which again is borrowed from game theory, to understand both the local importance of a certain variable and its global importance in predicting a certain outcome. I see that as an opportunity to marry the gold standard with machine learning methods so that you no longer have to constrain yourself with like a fixed model structure. And what's more unique about this is that you can even borrow some behavioral insights from the machine learning models to help improve the specification of a gold standard model and improve its performance. So I see that as an opportunity, and that hasn't been exploited to the full extent yet.
That's an interesting idea, I think, particularly sort of this marrying of data and modeling so that you don't pre-impose your view of the world necessarily on the problem, but you kind of take some clues. But then again, of course, it's the degree to which that makes our decisions and policies more equitable then depends on what kind of data do you have, and do you have the data, and how do you look at the data? So one of the things we often see in some of our projects where we really look at sort of the extreme impacts of climate hazards on communities is there's what happens in the majority of the population can be quite different to what happens in very specific communities. So to which degree do you feel like the data holds you back, or maybe what is the big challenge when it comes to data? Is it scarcity? Is it lack of representativeness? Where do you see sort of the data, both from an opportunity and from a challenge point of view? Do you want to?
Yeah, sure. Yeah, I have, since I work with data on a daily basis, I just have, I have to say, as a data scientist, 80% of your time is spent on cleaning your data. And that's probably true for every data scientist, I believe. So really, I agree with the previous talk that understanding the context is very important. And as a statistician, I want to quote George Box saying that all the models are wrong, but some are useful, right? So don't lose hope. Like even the data can be biased, and if you are aware of the potential biases, you may have like ways to correct it. For example, we once used the social sequence clustering method, trying to contextualize the decision context for various families that making choice decisions. And we quickly realized that there is a hyperparameter that you need to tune in for the missing values. Because if you compare like two trajectories of life courses, there are always some pattern missing. And we quickly realized that that's gonna really begin to create this artificial cluster where people seemingly to be similar, but in fact it's due to they have similar missing patterns. So we came up with methods to tune that hyperparameter so that with T-SNE visualization, basically it's in a high dimensional space, to make sure that bias goes away once we tune the parameter to some extent. And that will give us confidence that what left behind is something at least not biased by the structural missing. So I think most of these methods are case-by-case basis. It's really hard to tell you one-size-fits-all solutions.
I think that's a great point to generally, I think for work or research or applied work in equity, like one size rarely fits all. I'm sure that's an experience you might have had as well, Jessica.
Oh, absolutely. One of the huge challenges we're grappling with across the building sector and applications that will move us forward in that part of the economy is really generalizability and scalability. people will say, if you've seen one building, you've seen one building. We're confronted with extreme heterogeneity. And it turns out that once you have taken the published model form from the literature, tuned all of your hyperparameters with the data you may be fortunate enough to have, and then instantiated that for actual control in a physical environment, it doesn't transfer well to the next building typology or the next system configuration. Right. And so how to move forward with that is just really something that we're kind of butting our heads up against currently. Yeah.
Yeah, I know that feeling.
Yeah, I think I'll just try and rephrase the comment that I made before about assuming that the data gives us a complete picture. We're in the age of big data where, someone else has better numbers than me, but, as we're speaking, we're collecting data, right? We're collecting lots of data. I think, a little hormone is released in our minds when we see we have more data. We now, more reflective of, X. And I just want to encourage us to resist the urge to assume that it's giving us the complete picture because we know so much about how it does not. We know that, like as you mentioned, conditions for the most vulnerable are going to vary substantially from the mean, right? From the central tendency. And, I think as we continue to have this discussion, it'll slowly make its way into our practice. Mm-hmm. We have all these amazing brains in here that are going to go back to their fields and, with new light and new information and, new practices. And so I'm hopeful that we'll overcome that. But I think that many of our issues, they do stem from assuming that whatever errors exist, they're ignorable because we have more data now.
Absolutely, I totally agree with that. And that's also something that we always try to embrace is just accept the fact that things are biased, data will be biased, models will be biased. Just try to accept that and then constantly push back, right? Like constantly think about how could we do a little better? Like how can we fit this gap? How can we sort of move around this barrier? I think that's such a powerful idea.
So just to add a bit of optimism, we can get there. I think that it's about trying to work towards understanding the nuance and understanding how to apply data sets in different contexts. So it's not just about one size fits all, obviously. It's about making sure that we have clear guidance on how to apply different tools and different data sets appropriately.
Right. And I think one of the opportunities that data really does provide is also to make sure that the model doesn't get stuck in the past. So for example, we have done some work with our county during COVID, and one thing that was striking to me is the behavioral data early COVID was very, very different than a year later, right? Like so it's just the behavior changed completely, and I think that was very powerful to have that reflected in the data, and then have a model that adjusts to that new world of like things are moving forward, things are changing, and then maybe try to find a model that links the data and tries to stay in touch with people. I would love to hear from you, each one of you, and maybe we'll start with you, Ling, again, about one of the things that you tried and you thought it was a great idea, and then it just didn't work at all. So just kind of like one of those moments, I feel like I have a lot of those moments sometimes where I feel like this model would be great at this, this, and this, and then I try it, and it's just not so suitable. So any sort of learnings that you can offer where you thought something would really help you move towards greater equity and then it didn't quite?
Yeah, so I have two examples. So the first one is in the air quality modeling field. So we often think if you look around the research papers you found or where equity issues or regarding either exposure or health burdens were often evaluated as an afterthought, after you already come up with the energy or technology scenario, and then you evaluate multiple scenarios and compare their trade-offs, right? So I had an idea, how about apply the model, how about co-optimizing, like treating the each molecule of emissions differently, like judging its importance or damages based on where and when it's emitted. And however, then I did a back of envelope calculation. So once you have that, right, that would be great. You essentially have a geospatial and temporal data set that can be dumped into this optimization problem to do multi-objective optimization. However, then I calculated even on a supercomputer that would take about 50 years to run, right? Because all these sophisticated chemical transport models, and they are like incorporated state-of-art photochemistry and physics, and it's really cumbersome to run. So in my recent project, what I did was apply a different way to look at this, the problem. Like if you have a targeted community to protect, how about doing a reverse perturbation, like perturb the impacts on the community and see how it propagates back to all these input parameters, which is called the adjoint method. So by doing that, you only need to run the model once. You got all the parameters you need. So we've been generating that geospatial and temporal data sets, and we're looking forward to application of it. Like my dream is to having the justice, environmental justice, being evaluated as like a co-optimized together with the economic factors or greenhouse gas emission goals. And this data set will really help us to get there.
That sounds exciting. Jessica, do you have any things that you've tried and you're excited about it and then it didn't quite work out?
More than I would care to admit. One place I've definitely hit the wall was in the use of synthetic data sets. We have, so what do you turn to when you don't have sufficient measured data? You can turn to models, and particularly physics-based models. So we have really powerful models that have been built up over just decades of building science work. They're terrific. They can be exercised to represent all kinds of different typologies. You can get energy consumption profiles and equipment loads and indoor environmental conditions across many types. You can run these models at to understand different spatial and temporal resolutions, and then have a playground of data from the outputs. But what we very quickly will find is that those outputs are not reflective of the kind of stochastic variability that we observe in the field. And as it turns out, it's actually really difficult to mess up or noise up the data in a way that is realistically reflective of all the funky behaviors that we encounter. So the occupants opening windows and doors in winter while the heating system is on. That happens all the time. It's not reflected in the way that the models are running, or silent faults or problems that are lurking across all the equipment that you otherwise would never know are there, but are not represented in the idealized instantiation in the model that you're trying to use. Operator overrides, like on and on. And so we find that we're not able to then challenge enough our solutions in a way to get a solid understanding of how they're going to behave in the field. And I would offer a call for collaboration to anyone or everyone here to be able to develop the techniques to generate enough synthetic data that will have the typological variability, as well as the different operational modes that we need to see in order for our solutions to be robust.
And to briefly follow up on that, what is the role of these personal sensors, or like, for example, purple air, or like indoor air quality sensors that are becoming more abundant? Do you feel like that helps you get a better grasp on, people just forgetting to close the window? I have to admit, I'm one of those. I have to just forget. So what is the role of this sort of more personalized data?
That's a dream. More highly granular and resolved, measured data from our environments and facilities would be fabulous. The challenge being, do we have our environments instrumented well enough over, we don't often we have data sets of convenience as opposed to data sets by design. So I think that those are just the sort of solutions that we need more and more and more of. And the day of ubiquitous sensing will come, and we'll have more to feed our models.
Yeah, and I think we actually have data sets of convenience. We also have models of convenience. I think those two make a lot of convenience, but not always a lot of practicability. Tierra, do you want to share some experience from your end?
I'll, at the risk of someone pointing out obvious. So when I was doing my dissertation work, I was looking at regional travel demand models and trying to understand how to perform transportation equity analysis. And so this is given a model, let's apply the model to some set of transportation scenarios. And let's look at the outcomes and look at how those outcomes are distributed across various classes. So income classes, auto ownership classes, and so on. And the problem or the challenge with that is that at the regional scale, everything is, there's a need to aggregate. Sometimes in ways that are not so intuitive. And so there's an aggregation of projects. You might have one scenario that's comprised of hundreds of different types of transportation investments. And then there's also an aggregation of certain transportation dimensions. So, within the region of San Francisco, there are, dozens of transportation alternatives when you break down all the forms of transit, all the different levels of vehicle occupancy, all the different types of vehicles, and so forth. So there are dozens of alternatives that have to be aggregated. So you end up with aggregate transit alternatives and aggregate vehicle classes. And it turns out that when you're trying to perform equity analysis and understand how does accessibility by transit vary across the population, you end up with some results that are not so intuitive. And so, but that's the nature of how we apply these travel demand models in regions. And so in subsequent studies, what I've learned from that experience of, doing this, performing this analysis and arriving at my final results, which is this distributional measure, and it's like, okay, now how do I explain this? And it's based on how we aggregate alternatives. It's based on the classes of projects that we have that make up each scenario. And so, there's a need to understand how to right-size these tools. Another thing that I've learned subsequently is that, because of residential patterns, we still live in a very segregated society. We still cluster together, whether it's based on choice or circumstance. And the implication is that you can have whole communities that are sort of swallowed in these measures, and we don't actually understand whether this regional plan is going to benefit these communities. We just don't have a clear view of it. And so that points me back again to the need for us to have better guidance on how to right-size these tools if we're going to be serious about evaluating equity outcomes.
Yeah, and maybe tools on different scales that are interconnected. I could chat with you guys forever, and I greatly appreciate the privilege of being here and being able to ask so many questions. But I also want to give one of you a chance to ask a question. If there's a burning question on your mind and you didn't get it, that you would like to weigh in on, please raise your hand if there's something. I think there's a question by the door over there. Okay, sorry. There.
Hi, I'm Katrina, one of Jenny's grad students. I'm my first year of my PhD. So thanks so much for coming to speak to us today, all the panelists. It was so interesting. So I guess I'm quite interested in augmenting sparse data. So I think it's kind of related to the synthetic data question that Jessica brought up, or I guess the call to collaborate to come up with a solution to the fact there are so many variables in constructing realistic synthetic data. And I guess in my case, I'm interested in augmenting sparse precipitation data in the Arctic. But the problem there is that I think the problem is pretty much the same in that there's just a lack of data, or like spatially and temporally, and I think that also goes to what Ling and Tierra was talking about. So I think there are obviously a lot of issues that or factors that go into solving this kind of problem. And I think I'd love to learn more about specific solutions to, or what you think specific solutions would be to generating the synthetic data. Like, is it that maybe we have clusters or sets of data that specifically answer a very specific question with regards to the equalities or inequalities that we're trying to better understand. Yeah.
Thank you. Great question. We only have a few minutes left, so maybe a lightning quick response. Who would like to?
I would love to talk more off the podium with you. The short answer is, I don't know. We have some high confidence in limited data sets reflective of actual conditions. We have very good physics-driven models. We have extremely powerful statistical methods to understand and begin to characterize the stochastic variability that exists in the measured data. And how to combine those three things is it's an incredibly non-trivial problem, and that's why I say let's collaborate, because I do not know how to solve it.
That sounds great. I think there was one more question. If you can make it super quick, that'd be great.
Hi, my name is Hana Atik. I have actually a pretty basic question. One of the things that I feel I'm trying to explore is understanding what field to specifically choose within data science. I do understand that the skill set can be transferred, but how are you guys able to find your journey on what fields you want to focus on within the data science world?
Ling, what was your story?
That was a great question. Actually, I started as a master's student in energy resources at UC Berkeley. And one of the classes that the faculty members offer was climate uncertainty, and it's a major topic in one of the class. And I felt like, how can I quantify the uncertainties? And then I thought about the statistics. So I went to the stat department and got a second master degree in it. And then it turned out I was not that, I was too naive. Like, the uncertainties came from I think a majority from the in economic sense or policy sense, rather than the data sense. So it's so uncertain that you can't predict human in an accurate way. But I ended up acquiring the skills, and that helped me down the stream to since I got training in environmental engineering as well as resource economics. So combining the domain knowledge with the statistical skills I acquired made me a pretty good data scientist.
And I think this is a question we can all ask each other over lunch. How did you end up where you are? But I wanted to just take this opportunity to thank all of you for a fantastic panel. Thank you, Jenny, for moderating. Yeah. Thank you, Tierra. Jessica, Ling.